So how keypad interfacing works is the keypad is basically like a matrix. And so what happens is you see this 1, 2, 3, 4, 5, 6. Whenever you push a button, you create a connection over here. And now these rows and columns have voltages assigned to them. So it locates the thing which is pressed on the matrix, and like the processor also has a matrix like inside it. It like just imagines a matrix, and wherever it notices the connection, it automatically assigns the value. So there's steps mentioned over here for keypad interfacing. So what happens is all the columns have assigned value logic 1, and all the rows are assigned logic 0s. You can see that here. So next, if now the program scans, like I told earlier, it scans the pins connected to all the columns of the keypad. So it just keeps scanning all of this, and if it detects the logic 0, that means it's been shorted over there. And if it's been shorted, this R3, which is logic 0, would get connected to this, which is logic 1, eventually resulting in logic 0. And that indicates that a key press was made. And this is because the event of the switch press shorts C2 line. Yeah, so basically what happens is, in this case, they have connected this. When you press this, there's going to be a short. So this is going to be grounded, and this is already grounded, so that's how it pinpoints. Now, once the column corresponding to the key has been located, start writing logic zeros to the rows sequentially. So from here, you keep writing logic 0 to all of them. The procedure is followed until this goes low, and when logic low is already written to a low logic row. So that in that case, a logic low to the second row will be reflected in the second column. Once again, it's pretty self-explanatory. A logic low to the second row, a logic low to the second row will be reflected in the second column. And we already know that key press is happening at column 2. Now we have detected that the key is in row 2. So now you have row and the column. So you know it's at position 2 cross 2. Then you can name and provide it with a task, whatever you want. So let's look at the program. So yes, obviously this is standard. In keypad, you have to make the ORG 30H the place where you have your main program. So you has jump start, and now you have this move P0/FF. So basically you can just, instead of this, you can just write set bit P0. You're making it an input port. So yeah, that's why it's that way. Once you make it an input port, you initialize your LCD. Whereas the LCD initialization is the same as ever. You have your 3800, E0106, etc., etc. It's the same thing as ever. We've seen this already, so it's normal LCD initialization. Once that is done, you have to ground all the rows. So now you can see that port 0 has all the rows, and port 1 has all the rows, and port 0 has all the columns. So we're going to ground all the rows at once. That is, all the port 1s are being grounded, and read all the columns. So suppose there's a key press happening in any of the columns, that column will be set to 0, right? So if we read all the columns one by one, we can figure out which column has the button pressed. So that's why you're moving the column value to P0. Now A and L stands for and A and L stands for I'm not too sure what it stands for, but I know what it does. So what you're going to be doing here is, now you're not using all of the pins of port 0, right? You're only using the last 4, 0, 1, 2, 3. You're not using 5, 6, 7, 8. So first what you're going to do is you're going to mask the unused bits. So what you're going to do is an AND operation with A, that is these, and the 0, 0, 0, 1, 1, 1. So now how it works is, when you write something, right, it's port 0, 0.7, 0.6, 0.5, 0.4, 3, 2, and 1. Now if I do an AND operation with these, with if I do an AND operation between A and 0, 0, 0, 0, 1, 1, 1, 1, what's going to happen is, whatever values are there in this, I don't want any chances of errors. So if there's any value in this, ANDing with 0 is going to make all 4 of those 0, and whatever is here, suppose it's 0, 0, 0, 1, I'm going to get 0, 0, 0, 1. Whatever I have here is going to come back the same, right? So that's what's going to be happening here. Next, we have CJNE 0, 0, 0, 1, 1, 1, 1, K1. CJNE means compare jump if not equal. So it's going to compare the value in A, that is these, with 0, 0, 0, 0, 1, 1, 1, 1. If it is equal, that means nothing has been, it'll just go to the next line. Oh, one more thing. The result of this AND operation is going to be stored in register A itself. So once you finish this AND operation, whatever you get is going to be stored here. So now now what we have to do is we have to check if our AND operation, we're cross-checking that this AND operation was done successfully. That's basically why you have the CJNE line. Compare jump if not equal A and this, go to K1. So once you finish the AND operation, you'll check these two. If they're equal, you'll go to the next line. If they're not equal, you'll again do it, and then you're going to go to your next line. Where basically learn this if you're not being able to understand what I'm saying, but it's a check. It's a check statement basically. Next, you're going to call some delay, a 20 ms delay. Then to see if any key is pressed, again, you'll do the same thing over again. This is to test if you have already pressed in any other key. But in the exam, if you're running short on time, you don't have to write the K1 part, you can directly write this. But it's advisable to write both. But if you have very little time and you're in a rush, you can avoid this. Anyways, next statement, same thing as here. CJNE, if there's not equal, which obviously will not be equal, right? Because a key is pressed. Unless key is pressed, it will be equal. So that's what's in here. If 0, 0, 0, whatever you have in A is not equal to this, you'll go to over. Once you come to over, again, you'll do the same thing over again. This is another check. What happens is, like, when you press it, sometimes a double click might happen. That's why you have another check statement here. And this is one of the main reasons why you can avoid this K1 statement. Again, not advisable to like skip the checks, but if you have no time, you have no chance. You have no option, just do it. Next, after all of this is done, you'll go to this. So now what you're going to do is you've identified the column, right? Because you've done all of that, and now suppose I have pressed something over here, all right? So now this column will be grounded to 0. So basically, like, all the columns have a logic 1 assigned to them. But if I press this column will be grounded to 0. So the logic will be 1, 0, 1, 1, right? This will be 1, 0, 1, 1. Now once that is done, it's 1, 0, 1, 1. Basically, if you put it in an 8-bit format and if you consider the remaining bits, it'll be 0, 0, 0, 0, 1, 0, 1, 1. This is something you can just ignore. But yeah. Anyways, coming to the statement, now what you're going to do is you're going to ground the 0th row. Now basically we'll go row wise and we're going to see, like, okay, if I ground this row, is there any changes? If I do this, is there any change? Basically you're doing it ground row wise to identify. That's why you're going to do this first. Make port 1.0 and rest of them high, and then you're going to move that value. You're going to move the, like, in this case, P0 is the column, right? So we've assumed it to be 1, 0, 1, 1, right? So you're going to move 0, 0, 0, 0, 1, 0, 1, 1 into A. You're going to do an AND operation again, like we'd done before, to mask these 4. Masking is basically setting them to 0. Now you're going to do, what you're going to do is you're comparing this 1, 0, 1, 1 with this. If it is equal, you'll continue to the next line. If it is not equal, you'll go to row 0. That makes sense, right? Because that means that is pressed. To find the column, you'll go to this row 0. Let's see what is written in the row 0 statement. Actually, you know what? This is going to take some time. Let me just go here. So now once that is done, you're going to ground. If it is not equal, you will jump. If it is equal, you will go to the next line. So how do you know if it's not equal or equal? This AND statement is going to define it. This is something you should ideally be writing down all the AND operations and trying it out for yourself. I'm just here to be a guiding thing. but you'll do that and you'll check. Now, if it is equal, you'll that means it is not pressed. So you're going to just check for another row. So now, earlier we grounded row 0. Now we're going to ground row 1 and check. Again, you see all of this is the same. So keypad is not difficult, it's just very repetitive. So again, you're going to do the same test to find the corresponding column. You'll do that for the remaining 2 rows over here and here. And then you're going to, if none, false input, go back to K2 and repeat the whole process again. Now, in case something is pressed, you'll go here, which says move DPT row 0, move DPTR K code 0. What is my K code 0? You've defined byte C, D, E, F. Now, sorry, 0, 1, 2, 3. Now, here is where you're assigning the values for the keypad. This is like a 4x4 keypad, right? So that's where you're defining values. If you identify the row, you'll move all of these values into the DPTR over here, and then you'll do the find subroutine. In the find subroutine, you're going to do rotate right with carry. Why rotate right carry? As you'll keep doing it, suppose I have 1 0 1 1, I'll rotate right, the carry bit is still going to be 1, then again I'll do it's still going to be 1, then I'll do again, then it's going to be 0. So to check if any of the carry bit is 0, you're going to rotate right carry. If it is not 0, then you can jump if no carry match. That means if it is 0, it's the correct one, right? Because when you press it, only then it gets assigned to 0. So this is what we want, right? Jump if no carry match. After I do my rotate right, if I get 0, that means that button is pressed and that is match. So I'll go to my match subroutine where you want to print the value onto the LCD, right? This is your normal LCD subroutine, right? Clear A, move CA at A plus DPTR, then your LCD data, where you can see you have this. You've seen this in LCD interfacing. That's what's going to happen. In case there is no match, it'll increment DPTR and it'll point to the next one. So first it'll check for 0. If there's a match, great. If there's no match, it'll point to 1. If there's a match, great. If it's no match, it'll point to 2. So let's take, in our example, it's 1 0 1 1. First 1 will be put in the carry. Jump if no carry. Is there no carry? No, there is a carry. Screw that, go to the next value. Again, it'll rotate right. How will it go to the next value? It's going to do the rotate right operation. What is the rotate right operation in case you don't know? Rotate right with carry. Normal rotate right is basically you move this here, you move this here, you move this here, this here. Like this, you keep doing it. And the last bit comes to this. Rotate right with carry, what happens is there's something called as a carry flag, which is a bit which is set, which is provided like if a carry is generated during any addition operations, etc. In rotate right with carry, what happens is this last digit is going to go into that carry flag. And once that is done, there's going to be like, now this is going to become something 0 0 0 0 1 0 1, and in the carry flag you have 1. So what value will come in this something? It'll assign 0 automatically. It'll keep doing that till everything is set to 0. Unlike if you do it 8 times, everything will be set to 0. You can do it how many ever number of times you want. So so that is basically rotate right and rotate right with carry. So it's going now coming back to this. I moved 1. The statement was jump if no carry, but there is a carry. So what it's going to do, it's going to increment DPTR to the second digit, which in this case is 1. And it's going to sjump find. Again, it'll do the rotate right. Again, it'll keep checking until I have no carry. If I have no carry, then that means that I've pinpointed what my value is and I have to print that onto the LCD. So I'll just call my LCD printing subroutine. That's how it's going to work. This is LCD interfacing.